Galapagos is under parameters, right? And it's right here. So everyone knows Richard Dawkins went to the Galapagos Islands and established a theory of natural selection. So basically, the best genes or the best combination of genes leads to more optimal survival, right? So that's basically the idea here is in Grasshopper, you're establishing the values that the Galapagos component is going to explore and find combinations of, and then test those to be optimal, right? And you define optimal by maximizing or minimizing another number, right? So what that means is my rotation, right, can stay to the step, right? So it can manipulate how much it's rotating per floor. So I'm going to go ahead and click over here on the node for genome, and I'm going to bring it over to that number slider right there, right? So now Galapagos, when it's finding the best results, it's going to manipulate this number slider to do that. Now, my floor heights, right? Let's say my floors can be anywhere between 10 and 20 feet. So to avoid Galapagos to test against floors that are 2 or 3 feet high, I'm going to change this number slider. And I'm going to set the minimum to 10 feet and the maximum to 20 feet. That way, when I set Galapagos to test this number slider, it's not going to go below 10 and it's not going to go beyond 20. Does that make sense? So I'm going to also just come over here, select genome, and bring it over to that number slider, 12. So, now you see that it replaced actually when I had plugged in the rotation before. So whenever you're plugging in more than one input, right? So whenever you're like merging wires together in an input or an output, you want to hold shift. So for genome, right, to have more than one value, I'm going to hold shift, and you see that plus sign pop up next to the mouse, yeah, when I hold it. And I'm going to bring it into this number slider again. All right, now I click on Galapagos and I make sure, yes, I have 2 values that I'm testing with. So now I need a fitness, and this is the value that I'm either maximizing or minimizing, right? So it's going to, whatever I'm plugging into genome, it's going to find all possible combinations, and it's going to test for which combination produces the highest or lowest number. So this is where Ladybug comes in. I want to find out how much sun these floors are receiving, right? And find the rotation and the spacing for these floors that's going to reduce the amount of sunlight that they receive, right? Or maximize, whatever you're trying to accomplish. I'm going to go for minimize for energy efficiency, right? I think that's something that's important for D9, I remember. So now we get into Ladybug. So for Ladybug to work, right, you got to do some searching for videos probably, but after doing all that, if I remember correctly, right, first thing you start off with is you need this core Ladybug component, right? This component carries all of Ladybug's main classes, right? If you understand programming, you know that classes basically is defining what things are. If you don't define what radiation is, if you don't define what a sun is, if you don't define what a curve is, then the program won't know what to do with a curve when you give it to it because it doesn't understand what a curve is made of. So whenever you see like, oh, this defines main classes, if you research a little bit of programming, you understand, oh, you need main classes for the rest of the algorithm to understand what the heck is going on, okay? So if you search for Ladybug on how to use it, you'll know that you need this present. So I'll bring it in. Which time we have? 30 minutes. Okay. We're good on time. So right there, and then I hover over it, and it says, oh, there's a newer version of Ladybug, whatever. So whenever you get this error, it means this orange error with the message bubble, it means that something's missing, right? In this case, I may be missing out on the newer version, right? Or whatever they want to tell me here, but I know that this version is still going to be working. If you get a red error with a red bubble, it basically means you plugged in something where it wasn't supposed to go, and it's trying to read a curve as a number or something like that. But a yellow usually means you're missing information for the component to work properly. In this case, I'm going to try and ignore it and see if I can keep going. Sometimes it'll give you a red error, and it's still working, right? It's because it still is able to produce the result, so maybe the result that you wanted, but it's not working correctly. So it may lead to other issues in the future. It may not. Just be aware that you may get red errors, and it may mean that you need to correct for something. Sometimes it happens, and it still works. So just keep that in mind. Okay, so if you look up a radiation tutorial, right, which I'm giving you right now, but you can always find this online, you'll know that, okay, I want to visualize weather data, and I also need to analyze weather data, right? So, or we can start here at environmental analysis, right? So I go under environmental analysis, and I can test for radiation or hours of sunlight, right? I'm familiar with radiation analysis, which basically means the amount of solar energy that a surface is receiving or anything is receiving, so that works fine. I'm going to use that one. I'm going to plug it in here. And I have a bunch of inputs here, right? I can define north, right? Input a vector to be used as the north direction, right? It's already defaulted. Oh, no, it's empty. But I believe it's optional. I believe it can run without it. Geometry, right? Geometry for which radiation analysis will be conducted, right? So what are we going to analyze? We want to analyze these floors. However, it's not going to analyze curves as something that receives radiation. So we need to turn these curves into surfaces. So we go to surface, right? Freeform or primitive. I can look at primitive and I see that this is mostly 3D shapes. Not really what I'm looking for, unless trying to extrude the floors, but that's not necessary in this case. And go to freeform. After searching a bit for freeform, I can find boundary surface, create a planar surface from a collection of boundary edge curves, right? So I do have the boundaries of my floor plan, right? So let's see if that works. Plug that in, and there we go. Now I have all my floors as surfaces. So I hover over surfaces, 21 surfaces, right? And that's because I defined 20 floors here, and then I added the bottom of the lobby. So 21. So I plug that into geometry. Context, right? If I have buildings around, that's going to affect how the sun is received by these floors, then I can add all my contextual buildings and everything, so that adds to the information of how much energy this building is going to receive from the sun. Grid size, a number in Rhino model units that represents the average size of a grid. So basically, am I testing for how much radiation this square foot is receiving, right? For example. So because I'm working with a lot of floors, I'm going to define my grid size as 4 squared feet. Distance from the base, all right? So we can't really test what's directly going on that surface, right? That's because the surface is included as an object or an obstacle, right? So if we're testing for the surface, if we're testing how much radiation the surface is receiving, but then at the same time in this process, that surface is also in its own way. It's like overlapping with the test area. So you want to offset by maybe a 1/4 inch, right? So that way you're based off of that floor, but since that floor and your test area aren't overlapping, it's not going to corrupt your results. And that's just something you find out by testing this component and using it. So I'm going to go ahead and do 1/4 foot offset for my study. Now, orientation study, I know this is optional, so I'm not going to go for it. Now, selected sky matrix, the output from the selected sky matrix component, right? So this is a sky matrix, right? After researching this a little bit, you notice that a sky matrix is actually the information of the presence of the sky, right? So it's a dome, right? And it's a dome that has certain paths that the sun can follow, right? And if it's a selected sky matrix component, that means it's a specific component in Grasshopper of the Ladybug plugin. So let's look for it. We go to Ladybug. And now I understand that sky matrix isn't really part of environmental analysis because this is the analysis, right? I understand that a sky matrix isn't really analyzing anything, it's representing something, right? So I can deduce, I can search a lot, but I can deduce I need to go to visualize weather data. And under here, I in fact find Ladybug, select the sky matrix, right? And I plug that in. This looks really complicated, but I'm straight up just explaining to you how the plugin works. And this is all online, you can find yourself. And this video will be available to you, so. Cumulative Sky Matrix, right? So now I know that I need the output from a generative Cumulative Sky Matrix component to select that sky. So I need to generate this sky in order to select it for the analysis. And when I went to visualize, I actually saw that one right next to it. Generate Cumulative Sky Matrix. So I plug that in there, right? And now if you notice, this wire is yellow or orange, right? And that means there's data missing. So if I hover over selected sky matrix, it's empty, right? The selected sky matrix for the input hour of the year or an analysis period. So the output is focusing on the analysis period input. So I know that I probably need to have that data to make it work, right? So analyze weather data, and I know analysis period is here. You can also just search for it, right, as it appears there. Analysis period, Ladybug analysis period, right? Analysis period. And then I know, okay, I can test from, right, a number between 1 and 12 that represents the month of the year. So I can test from January 1st, from noon, right, to December 1st at noon. See what I did there? All good? Okay. Still orange. What's going on, right? So hover over here. Input hour of the year analysis period, I already did that. So maybe I can mess with these, but I'm not going to waste my time or yours. I know what's going on is here. Run it, right? Set to true to run the component and generate a sky matrix. So this thing won't actually calculate anything until I tell it start calculating, right? And it says set to true, right? This is some confusion because in Rhino, when you do a Boolean, it's like solids, right? You're like removing solids from each other, Boolean difference, Boolean union. That's actually the only use of the word Boolean I've seen. In Grasshopper, those are called solid unions or solid differences. In programming, Boolean is either a true or false condition, right? So if I search for Boolean, and this is what I want, a Boolean toggle. Boolean set true or false toggle, right? And this is essentially a switch that goes from false to true when I double click it here. So I'm going to keep it on false, but I know that when I switch it to true, it's going to calculate everything. Last thing, I need my EPW weather file, right? And this is something you're learning about in environmental class, that you need these weather files to receive the data on the region. Man. So you can Google for that. I never remember where I have it on my computer. Weather Miami EPW file, right? Florida weather data by region. Miami International Airport, sure. EPW file. Download it to my desktop. Go back to Rhino or Grasshopper. Okay, EPW weather file. And I hover over it, the output of the Ladybug open EPW component, right? So there's a Ladybug component to open that file. So I search Ladybug open EPW weather file, right? You hover over anything in Grasshopper and it's going to give you clues as to what you need, right? Even if you don't understand how it works, even if you search the YouTube videos and you don't understand, there's a way to move around in here where you can deduce it yourself, right? So with the open weather file, I'm going to connect that here. And I'm double click on open, or, right? If I hover over open, it'll say set to Boolean to true to browse for the file. So there you go. So I need another Boolean file. Is the script getting a little messy, or are you guys still able to follow along with me? It's good? Okay. So I'll turn it true, and there we go. I can search for that file, go to desktop, there it is, I just downloaded it. Boom. So now I set Miami as my location, right? Now I want to run the generate the sky, so I set that to true. Calculating, it will be closed automatically when the calculation is over. It may take a few minutes, so I'll wait. It even knows my name.
So the Boolean toggle is just another way of saying turn on or turn off.
Right, like run or don't run, or right, or whatever the component is set to that Boolean, right? So for example, when you're doing a loft and you have loft options, there's some options for when you loft things. Do you want the loft to be closed, right? Or do you want the loft to be this or that or whatever? Like when it's a yes or no, it's a true or false. Calculating direct component of the sky. Okay. How are we doing on time? All right. There we go. Oh, not so much. So this is where we're getting a bit heavy on the computer. So you want to have pretty much everything, like all your parameters set at this point, right? Because at this point it's doing a lot of math, it's doing a lot of calculations. You're going to have to let it load for a little bit. So don't mess with all your other values, right? Make sure you have that part of the algorithm set so that you're more efficient and you can focus on this data happening right here. Okay, so we look over here. We have our sky matrix in there, cool. Orientation study parameter. That, you know, as much as you can add to the analysis, the more accurate results you're going to have, right? But I'm going for the minimum to make this work. So everything underneath this dashed line isn't necessarily adding information to the study, right? Bake it, all right, that's taking it to Rhino. I'll cover that at the end because we want to export this to Revit for you to use this optimized configuration in Revit. So I'll explain what baking is later, but I can see that the radiation analysis also has a run it component. So I may have calculated what my sky is, but I haven't calculated my radiation yet, right? So I'm going to hit run it with a Boolean toggle. Right? This is in kilowatts per square meter, right? That's what we've seen on the legend back when we go back here. Right? It's kilowatts per square meter, and that's what these numbers are, and we can see the scale of it here, right? And it being represented in colors, right? So I want the overall radiation to be reduced, like the least amount of heating energy that I can get into this building as possible, right? So what I'm going to do is I'm going to simply take the total of all this, right? So I'll do an addition, or here we go. I have this component. I'm not sure if it's native to Grasshopper or if it's a plugin I have. Yeah, mass addition. So rather than using the addition I used before where we added one number to another, I'm going to use mass addition because the description on this one is perform a mass addition of a list of items. And that's what I have. I have a list of radiation results. So I'll plug in those results here, right? I'll get a number parameter component here. And now this number, oh, so you see it's not adding them all together. Why? The dashed line. It's branched out. They're separated in different groups, right? Again, people have a hard time understanding grafting and flattening, but basically, if what I'm expecting here is one number, and I don't have just one number, and I see a dashed line, I can understand things are being divided, so I can flatten it here. And there you go. This is the total amount of radiation that the entire building receives. And this is the number that I want to get to be as small as possible. So here's my Galapagos, and this is just my fitness for Galapagos.
Can you just reduce the floor?
Yeah, so it doesn't take so long. Yeah. So let's just test for 3 floors. And I'm actually going to make the grid size like as big as I can actually. So the reason I'm doing this is because otherwise we'd be sitting here for like an hour waiting for the best results. So we're just going to do 4 floors and we're going to make the area 8 squared feet, right? So now we double click on, we're set, right? I have my parameters, right? I'm testing for rotation and spacing of the floors, right? I set that number slider for the spacing of the floors to be between 10 and 20 so that it can actually be usable, right? And I have my result, my radiation result to test against, right? So I double click on Galapagos. I want to minimize my fitness. I want to minimize that radiation number, that total radiation. Runtime limit, I want the analysis to run for a maximum of, say, 5 minutes. And while that happens, I can answer your questions. right? This is all fine. I can, you know, investigate and modify all these things, but generally you can just leave those as is. Here you have a textbook, literally, but these are chapters on how to use this plugin, not this plugin, sorry, this component in Grasshopper. So if you want to really get into it, you can look through these, but generally you can just maximize or minimize whatever you're working with and set a time to do it. Then we switch to solvers, right? Now, a couple things here. We want to have this one selected. Use the evolutionary solver. Basically, the evolutionary solver, whereas this one, right, simulated annealing solver, there's basically just like different ways of deducing how to get to your result, right? Do we like go random, and then say like, oh, this number works, and keep randomizing this, right? Or the evolutionary thing, which is saying like, oh, these range of numbers are working better. Let me stay within this range and see what works better and narrow that down, right? So I'm going to keep it to the evolutionary solver. Then here is what we're going to preview in Rhino. So here I have it set to only display the best results, or the best results so far, right? And here I can set it to display all the results. So I want to see first everything. What does it look like when it's completely going through all the results, right? So I'm going to start the solver, and hopefully it doesn't crash. Wait. I'm going to save. To the desktop. Sarah D9 Lady Workshop. Okay. So, oops, sorry. I'll double click and then I'll run it now. So I'll hit start. All right, and what you'll see here, once it starts gathering some results. So remember how long it took for it to calculate that radiation, right? That's basically what you can expect for it to take to calculate every possibility, right? So if you're going to go through like 50 possibilities, you might as well just leave your computer overnight calculating this thing. And the next morning you can review all the results and the best ones and then use that in Revit, right? In this case,